Hi, everyone. Thank you for joining us in this session. My name is Caroline Chan. I'm a Vice President and General Manager at the Intel Network Platform Group. It's my honor today to share some of our recent partnerships to drive innovation in the ORAN architecture. So ORAN, what it does is it open up a lot of interfaces, introduce new APIs, really allows a service provider to start digging into and leveraging the network data for real time for improved performance. Especially, they introduced this concept called RAN Intelligent Controller or RIC. So data can really be acted upon and developed to produce meaningful impact on customer experience, monetization, and beyond. So Intel has been active partnership in the ORAN standardization along with VMware, and especially the real-time and non-real-time RIC. So today we're going to spend some time and have that discussion with our partners in this. I'm happy to be joined today by Dan Weil, COO of Cellwise, Dolan, Chairman and CEO of Cohere, Chao, CEO of Pote, a location-based company, and Ravi, VP Technology of Capgemini Engineering, formerly Altran. So let's start with Dan at Cellwise. So Cellwise is a company that really all about the network, enabling the network of the future today. The product is called Chime, Chime. It is a cloudified and AI-driven RAN automation and orchestration platform. So they enable the mobile networks operator MNOs to accelerate 5G network deployment and go to market, as well as the ROI for the network investment. Even in the most complex and dynamic network environments, Chime enables operators to connect to and applications and any vendors as well as co-create on top of the platform, deliver unprecedented ease, speed, and agility. So with that, I would like to introduce Dan. Dan, thank you for joining us. First question I have for you, what are the three must-haves of next generation RAN automation platforms or frameworks? And how do you think that will benefit mobile network operators?
I think the number one must have for next generation RAN automation frameworks and the RICs is the backward compatibility with non-ORAN network elements and multi-vendor, multi-architecture support. This will enable a unified process across traditional RAN, vRAN, and ORAN. And I will connect that the second must have is a platform that provides the flexibility and modularity which can enable existing RAN tool in the MNO toolchain architecture to enable a gradual and controlled transition. This is a key from an MNO to be able to reuse existing investment and to drive toward the transition. And last but not least is the capability to utilize intelligence function based on complex event processing and machine learning for enabling a surgical approach for automation and autonomous network optimization at the speed of the network. This is a shift in the current mode of operation with regards to RAN automation, which is going to dramatically change the value automation can bring into network management.
Thank you, Dan, for the answer. And that was very, very interesting. So I have a follow-up question. So what are some of the key functions of non-real-time RIC and the RAN SMO components that are required for operators successfully implementation?
When looking at what is required for successful implementation, I think that there are key for successful implementation is a platform that addresses the operational capabilities, which will allow to meet the real-life network management requirements of an MNO. This includes capabilities to define network design, operation policy, regional control, conflict management, and much, much more. This will allow to take the promise of non-real-time RIC and the RAN SMO components to the nationwide scale. In addition, a key aspect of the non-real-time RIC and the SMO is the enable faster time to market of innovation To achieve this, the RAN SMO and the non-real-time RIC need to be driven by advanced CI/CD and AI ops practices to allow MNO to push automation function into the network from idea to production deployment in weeks. This is also a key that the platform enable MNO transparency and observability of the operation of the automation to allow the MNO to gain the trust in the platform and the network automation use cases. One more thing that I wanted to mention, we are on a journey to ORAN. It's already started, there is no doubt about it. From our view of the market, most of MNOs have already started to work in their ORAN strategy, and we're looking to see production implementation within the next 18 to 24 months. As the specification is still evolving and RAN vendor compliance level is still not complete, operators will have to follow an incremental implementation strategy for ORAN and vRAN alongside their traditional RANs, and will need to implement a flexible and holistic management framework to enable such transition.
With that, let's go to Ray Dolan, Chairman and CEO of Cohere. So first, let me give a brief intro what Cohere's mission has been. Cohere has been gaining a lot of attention lately with the spectrum multiplier software for the existing TDD as well as FDD RAN. And it's really an ASAP on the RIC for the Open RAN, the real-time RIC for the real Open RAN. Earlier this year, in partnership with VMware, Capgemini, and running on top of Intel platform, Cohere has demonstrated the multiplier effect on a 3.5 gigahertz 5G TDD with Vodafone. So it's been a really good performance and generated a lot of buzz in the industry. And last year, Cohere actually did the same in 4G with Deutsche Telekom in a commercial 1800 megahertz band, also based on Intel FlexRAN and VMware. So Ray, I got 3 questions for you. So let me start with that, and looking forward to some of the discussion we have. So how has a partnership with Intel and VMware made a difference for your customers?
Oh, it's been fantastic. So thank you for that kind introduction, Caroline. We've had a partnership with you and Intel, as well as VMware and Capgemini for the better part of 2 years. You highlighted some of our major milestones already, but just to be clear, we did an initial demonstration in Deutsche Telekom. We did a subsequent one in Vodafone. They were different, but they kept coming back to the same common outcome, which is if we inserted ourselves as an XApp in a RIC, we could double the capacity of the network. And that's just huge when you consider the hundreds of billions of dollars that people have spent on spectrum and assets around the world. So it's been a tremendous partnership. Particularly valuable is how committed both VMware and Intel are to the Open RAN architecture, which is really the architecture of the future. The world is going to go, as you said at your introduction, into a new set of APIs, a new set of interfaces, a new supply chain. It's going to welcome in people from the compute industry, the cloud industry, the software industry. It's extremely interesting. And I've been in this industry for 35 years. This is like the high point, if you will, of my career, is really opening up the black boxes that have been in black boxes forever in wireless and allowing new blood into the ecosystem. Intel is the foundational layer. You personally, and as I'm part of Intel, have been committed to this space for 10 years now, and you're reaping the rewards of that investment. You guys are out there leading the world into an Open RAN silicon architecture with a PHY layer. Those are the assets that we levered. Of course, Altran, Capgemini was an important part of the stack. VMware is a very important part of the RIC. That's actually the box that hosts us. So the RIC from VMware is going to host our XApps, and our XApps are going to do all of the channel modeling, the beamforming, and the scheduling that's currently done inside base stations today.
Thank you for that, Ray. And we talked quite a bit about the trials that you have had done. If you want to share a little bit more, as well as when can we expect to see a commercial available spectrum multiplier XApp?
Well, so Caroline, our XApp is live on the VMware RIC, consistent with what they've just announced as far as their availability. So So that XApp, that RIC will be available by the end of the year. We'll be running on it, and then we'll continue to evolve and add more and more functionality beyond that initial launch. But certainly next year in 2022, you're going to see a lot of operator interest and potentially even some commercial deployments with our XApp on that VMware RIC. And it's a very powerful concept. Understand that RIC is a hosting engine that's going to have open interfaces, will be one of a suite of XApps that VMware will offer to their customers. And our XApp will be focused mostly on spectral efficiency, network slicing, and scheduling, all right, which is in a lot of ways the heart of what a base station does today. So we'll have taken a significant amount of the base station intelligence and made it available for those operators that want to start exploring cloud RAN deployments, which are going to have a significant benefit from the standpoint of their economics, as well as the strategic benefits of being able to take that into the enterprise.
Wonderful, wonderful. When you started hearing about 6G, I know Cohere has been OTFS for over a decade. What can we expect from Cohere in 6G?
Well, OTFS is our play. It stands for orthogonal time frequency space. So the space is new. We're going to create a spatial multiplexing capability right in the waveform. It's going to be far more resilient, far greater link budget, which means more capacity, far more consistent across the area of the base station. So it won't be just strong in the near field. It'll be strong in the far field. There's so many merits to that. You can think of it from our point of view, it's an option. Our primary business model is to solve the 4G, 5G transition into much greater capacity, drive into the enterprise, and open the network architecture. But we're also going to have something to say about 6G as the industry debates it. And it's important to point out that 4G and 5G didn't do anything in the transition from 4G to 5G to change the waveform. It's the same waveform that started in 4G, got modified very slightly in some nuanced ways to create 5G. 6G will be the opportunity for the industry to really innovate at the waveform layer. That's where we think OTFS will shine, and we think that'll happen sooner than people think. I think in a few years, you're going to start to see some meaningful commercial trials looking at whether 6G can, in fact, continue to address high performance with full mobility better than 5G can do today.
Thank you, Ray. That was a very insightful discussion. Now let's turn to Pote and the CEO at Chao. So Pote has been an innovator of the cloud location over cellular technology. They provide secure, accurate, and global location solution that really empower the enterprise with real-time visibility into all the things that matters. So simply leveraging the 4G, 5G cellular infrastructure and the cloud computing, Pote is able to fill the gaps in location intelligence for a wide range of IoT devices, from massive IoT to critical IoT indoor and outdoors across both private networks and operators. With this deep domain expertise and all the essential patterns they own, they are transforming what is possible with asset tracking, enabling all the promises of 5G precise positioning by demonstrating location for supply chain, logistics, manufacturing, and a wide range of other sectors. So welcome, Ed. I have several questions for you. To start with, you have talked about Pote being a very unique enabler of true 5G precise positioning. Why is that, and how would that benefit all the enterprises?
Yeah, Caroline, it's really not just about our deep domain expertise, but it's also our approach. We look at location as a system with the end customer in mind. The big industry challenge for enabling 5G precise positioning is that vendors generally think of location just as a feature on their product. The reality is there are a lot of parts of the system that come together to fully unlock the potential of 5G precise positioning, in particular for enterprise transformation. From private to macro networks, from edge to cloud, the parts need to come together to enable and support all the needs of enterprises. What this is secure, accurate, and global positioning that's going to truly meet the needs of digital transformation. And it's industry initiatives such as Open RAN and the RIC that will unlock the full potential of 5G precise positioning.
Thank you, Ed, for that. This follow-up question, what sort of use cases do you think that the 5G precise positioning can enable?
There's lots of technologies that do positioning. First one we think of is GPS, and the problem with that is it only works outdoors when you have line of sight to the sky. And there's other technologies like Wi-Fi, BLE, and UWB, but they only work locally and you have to deploy lots of beacons to cover a large area. But 5G precise positioning promises to meet the needs of all the needs for enterprises: secure, accurate, and global location. This applies across many use cases, across many verticals and industries. Polte sees this fall into two key categories: massive IoT and critical IoT. For massive IoT, the main set of use cases this enables is ultra low-cost battery-powered asset trackers that enable real-time logistics and supply chain visibility. For critical IoT, it's Industry 4.0 and smart warehouses, and applications like connected cars, robotics, AR, VR, and drones, where positioning is fundamental.
Thank you, Ed. So one last question for me. What do you feel is the biggest challenge that the solution providers face today when they enable 5G precise positioning?
Look, the biggest challenge, just like it is with anything in this industry, is deciding which technologies to use to meet the needs of certain use cases. The great thing about 5G is that it reduces a lot of those choices and complexities by combining high speed, low latency connectivity with the innate capability of precise location, down to the sub-meter X, Y, and Z level. This gives solution providers and system integrators all the tools they need to meet the unique needs of enterprises, giving them the freedom of choice of vendors to enable location and innovation. And ultimately, that's exactly where open interfaces, and in particular Open RAN and the RIC, come in. The RIC, both near-time and non-real-time, enable innovations like 5G precise positioning to be fully realized. And it enables startups like Polte to work with companies and innovators like VMware and Intel to really bring that and accelerate that capability to market.
Thank you, Ed, for that very insightful conversation. So let me introduce the last guest of today's session, Ravi, VP Technology of Capgemini Engineering, formerly Altran. Capgemini Engineering combines under one brand a very unique strength from across the group, the world-leading engineering and R&D services for Altran, and Capgemini's digital manufacturing expertise with a very broad industry knowledge and cutting-edge technology in digital and software. Capgemini Engineering supports a convergence of a physical and digital worlds combined with the capabilities of the rest of the group. It helps the clients to accelerate their journey towards intelligent industry. Well, thank you for joining me today, Ravi. I have a couple of questions that we can dive in a little deeper. The first one, what are Capgemini and VMware working together, and how does that benefit your customers?
So Capgemini and VMware have started to work on realization of a RIC-based solution, right, which is aligned to the ORAN specifications. What we see is like RIC is going to play a very key and integral part of the 5G and 5G plus journey. And towards that, there are three key pieces. One is the changes required in the CUDU, support in the CUDU of the G node itself. Two, the changes in the RIC itself, which is being developed by VMware, and then the XApp. So these are three key components. What we see is important as we go forward. And Capgemini has been working with VMware team on the CUDU side part of it to support the E2 related termination in the service models and the definition for various use cases. And we are also working with VMware team actually on the XApps for some of the other use cases as well. And for this particular use case of the MU MIMO, we're working with Cohere to bring their XApp, VMware RIC, and then the Capgemini is actually CUDU integrated with the Intel FlexRAN 5. So it's an end-to-end demonstration done, but as a part of the specific journey, right? The E2 and the necessary changes in the CUDU, the RAN part, and the necessary integration interface with the RIC is what we have been working with VMware.
Thanks, Ravi. Follow-up question, how does the solutions integrated with the VMware's RIC?
Yeah, so there are two parts when you talk about a RIC and the CUDU, right? So one part is actually the cloudification, which is also a very important aspect of a 5G plus journey. The second is the RIC itself. Now, if you look at, there are two parts of this. So one part of the cloudification, right, we have taken the VMware TCA platform, and then from a CUDA perspective, we actually transform that as a container-based solutions, which means you have CU user plane, the control plane, and the DU, which includes the PHY, and as containers. Now, these integrated with the VMware TCA platform. That's a part one of the story. The second step is the RIC itself. Right? When we talk about the RIC, there are two parts. One is the E2AP, the signaling flows which happen, and the second is service model on which use cases can be built. Right, so we have defined for this particular use case, the MUM use case, the service model doesn't exist in the RAN specifications. So build actually E2 service model jointly, and then integrated to that with between the CUDU and the RIC itself. So this is the key activity which is carried out as a part of this. And end of the day, right, the end-to-end solution of the CUDU launching as a containers, then be able to run the right use case, an end-to-end setup with the MU configuration scenario, CUDU integrated with the RIC and then the XApp, and demonstrating the benefit. All of these were jointly done with VMware and the partners.
Thanks. My final question, what do you hear from the customers about the RIC? And what are they looking to deploy?
So what we see is first, customers want to understand the benefit of RIC. So while RIC is a very interesting concept, right, there are not many deployment results which are available. First, they want to understand, while theoretically it's right, it's very good, but on a practical basis, how do you actually get a benefit out of it? That's one thing customers want to understand, and then right, build some reference use cases to prove that. That's one part. The second part is when you have multiple XApps and high capacity and load to be taken in the system, is that going to be handled in the RIC, and you have multiple XApps? Trying to optimize a common set of right parameters or SLAs, right? That's a very tricky problem to solve. So that's the second part of it. The third part, what we see is a lot of the SON applications, right, which are there in the 4G world. How can those be transposed into the RIC platform, right, with some of those running as an XApps itself, and trying to get a benefit and leverage out of it. Now, when you talk about all of these three, there is also a few other implicit activities which is to be considered. One is, right, as a part of the applications, when you are building it on the platform, how do you deploy and take benefit of a machine learning models out of it? Right? That's one interesting use case they were, customers and operators are trying to understand. And finally, it's all about what value add, what are the differentiators you can bring with the RIC in place, and the amount of data which is available in the RAN. How do you actually build your own proprietary application on top of the RIC and provide a differentiator? That's a final part of it. So these are the trend what we see the customers are looking for. And Capgemini, along with VMware, the partners are trying to work on some of these aspects, right, covering all of the items as I mentioned, and then try to have a solution which can be right, aligned with the RAN specifications and also meet the customer related requirements.
Well, thank you, Ravi, and thanks to all my guests today. I'm looking forward to see how all the applications and RIC technology really transform the industry and adopted by all the MNOs. That's all we have time for today. Until next time, goodbye.